Hey Google, turn on lights. Let's rename the stream. As you are walking to yet another connecting flight, you realize that one of the legs of your rolled trip coming up is on a high-speed train. However, the train ticket you were given in language you don't understand. You should probably figure out what it says before you get to the train station after the next flight. Unfortunately, you can't actually read the words on the ticket. You can, however, read the numbers, and so you figure out the fields these tickets must have and the valid ranges for values in those fields. You collect the rules for ticket fields, the numbers on your tickets, and the numbers on other nearby tickets for the same train service via the airport security cameras, together into a single document you can reference. The rules for ticket fields specify a list of fields that exist somewhere on the ticket and the valid ranges of values for each field. For example, a rule like class column 1 to 3 or 5 to 7 means that one of the fields in every ticket is named class and can be any value in the ranges 1 to 3 or 5 to 7, inclusive, such that 3 and 5 are both valid in the field, but 4 is not. Wait, why? Yeah. Each ticket is represented by a single line of comma-separated values. The values are the number on the ticket in the order they appear. Every ticket has the same format. For example, consider this ticket. Here, question mark represents text in any language you don't understand. This ticket might be represented as 101, 102, 103, 104. Okay, so only numbers. Of course, the actual train tickets you are looking at are much more complicated. In any case, you've extracted just the numbers in such a way that the first number is always the same specific field. In any way, you extracted just the numbers in such a way that the first number is always the same specific field. The second number is always a different specific field. Okay. Start by determining which tickets are completely invalid. These are tickets that contain values which aren't valid for any field. Okay. Ignore your ticket for now. My ticket? For example, suppose you have the following notes. Your ticket is 7114. Nearby tickets. Okay, it doesn't matter which position corresponds to which field. You can identify invalid nearby tickets by considering only whether tickets contain values that are not valid for any field. In this example, the values on the first nearby ticket are all valid for at least one field. The values on the first nearby ticket, the value 4, 55 and 12 are not valid for any field. Adding together all of the invalid values produces your ticket scanning error rate. Okay. Consider the validity of the nearby tickets you scanned. What is your ticket scanning error rate? Okay, so for example, suppose you have the following nodes. So let's look at my puzzle input, because I don't understand the format yet. So is it written your ticket? Okay, fair. So we can split by 2 new lines, which I don't really need, but okay. Okay, or and interesting. Do we have more ors? No, I guess we can have only one or, and we always have or. Ah, I see. So we are not actually parsing the ticket. I would exceed or perfect this exercise with parser combinators, but okay. So your ticket is given to you, so no matter class fields and so on. Okay. So that's really easy task to do. So we will need. So we have bunch of intervals, and we have bunch of pairs of intervals. But it doesn't matter, because in the end we have just bunch of intervals, and what we can do is just to check each number whether it's in any interval. So we can do the optimization. Actually we need to analyze our input to get the proper optimization. 16. Uh, 14 main. 14 main. So in our input we have okay, so actually here we have about 20 classes, and we have seeds that values intervals that don't exceed 1000. But we have a lot of numbers, really a lot of numbers. So if we choose to use algorithm which checks each number towards every interval, we will got like number of tickets multiplied by 20. But if we say that we will spend 1000 iterations, no, it should be more than 1000, right? So if we want to create an array or a map of saying like which intervals can be valid numbers, which cannot be, we will spend 20 or 40 intervals multiply by their ranges, which is 1000, like be the top estimation is 1000, so we will have 40,000 iterations. And so we need to compare what's better, 40,000 iterations plus the number of tickets, which let's estimate we can do this nearby. Of course I can input already, but let's check my Vim skills, and we will, I can first write a parser and then to determine number of tickets, but I also can do a replacement. I can replace every comma with /n. yeah, sure. So how we do /n? No. Vim said new line. Use /r instead of /n. To get a new, I use /r. /n and /n. Okay. I don't understand, but okay. /r. It worked. I'm not sure what it does. Okay, but what we've got is we have 5,000 numbers. So we say 40,000 plus 5,000. 5,000 is not that bad. So 5,000 multiplied by 40. Actually, by 40 it will be 200,000. 200,000. So 40,000 plus 500 is much lower, like by the degree. About 100 times smaller. So 40. Yes. So constructing a map would be a better solution here. Yeah, so basically what we're doing here, if the number of tickets is substantial, like here is 5,000, but our tickets, like we will have repeated numbers here. But because we don't store, still, even it's not 5,000, 1,000, you will need to do 4. You will get, if it's 1,000, you multiply by 40 and you get 40,000, which is similar. Okay, yeah, so I just missed the point that we actually have we have numbers that are repeated here, but it doesn't matter still, because 4,000 for the improved algorithm would have been the top estimation. But for the trivial, the obvious algorithm, it would be like just exact estimation. So I still think that it works to use improved algorithm. This array or map is redoing array or map of valid numbers, and then just checking whether the number is in the array or not. So our example is this one. I actually need to so name of the field and intervals, constraints. Yeah, let's say intervals. We are using list and not pair, just to be able to extend to multiple constraints. Of course, our list shouldn't be empty, but we can extend the behavior to fit if we need to. Munch not equal column. Name. Yes, sounds about right. Then we have spaces. Then we have Munch is digit. Also we can not hyphen, but let's say is digit. And we have many, right? So let's use separated bar. Yeah, because I think it's not spaces, it's just space. No space. Browse text, parser, combinators, read path. Space, 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 no space at all. That's interesting. But for sure I remember having spaces. Maybe white space or channel skip spaces, I see. Skip spaces. Yeah, it's working. Nice. So let's say we have interval. Read interval p read p, which return int, and this interval will have low munch is digit, p character hyphen, and high p munch is digit, and will return low and high. And so here we will have parser combinator sep by, and let's say sep by 1. Just not. It will have. It will parser will fetch if there is no no constraints at all. So sep by 1. Interval, then we have pass string space or space, and then interval. So the thing with sep by is that we'll have multiple reads, because sep by is implemented using many, right? So that's result field. No, we have name and we have intervals. So that would be interval. So we will return field name intervals. Couldn't match with int, right, because set by interval int, yeah, you will need to have read here, and that's totally fair. Read. So now what we want to do is to say read please field name and constraints 1 to 3 or 2 to 4. or 2 to 7. What will it do? And we say it's filled. Now parse. That's super interesting. Oh, right. Pay much because I haven't read. No, because my. Okay. So we say we have also a character column. I forgot about column. Column spaces. But yeah, I think we can do the operator here. Yeah, understandable, because not understandable is why don't we have error? Like what's wrong and what's expected. Parser combinator had this. And that's what's beautiful about them. You just specify declaration about what you expect to read, and they automatically create you error messages. Like at the character 14, we expect it to be either this, and none of that, so that's why we fail. But I guess, yeah, so learning parser combinator library would be better than standard parser combinators in text. Yes, but I'm already learned, so I don't care about relearning. If you use projects with parser combinators, certainly do, but for now doesn't matter. And what's interesting is we had the single parse here. What if, for example, we had space? Totally okay, interesting. So even though SEPBY uses many, it might not use many actually. Okay, if not, that's perfect, just perfect. So we read field, we need to read the ticket. Yeah. Let's say that ticket contains just the numbers. Ticket int I actually can read lists, which is super handy. Read ticket, where read precedent, lift, do. I guess we can just implement a functor for ticket and just say fmap read. Yeah, we can do that, but I don't think it will work. But doesn't matter. What we'll do here is we have function read, which is just read. So why don't we use read here? Wait, we also have read precedent, so we can just say read precedent ticket. Isn't that genius? So we're reusing read precedent for list of ints, but not specifying anywhere the list of ints, because ticket expects the list of ints, so the compiler will know we need to use a function that returns the list of ints. My assumption, yes, it's perfect. So we need to read the nearby tickets. So let's say we also have data input file. Which will have a list of fields. It will have my ticket, the type of ticket, and it will have nearby tickets. Yes, so it will work if we just define read for input file, where read precedent is the lift, and what we want to read is be separated by /n, right? /n. What we are reading is field. Read prec separated by char /n, and that's our fields. Then we are skipping spaces and we are reading string your ticket /n, and then here we read my ticket, which is just read precedent. Then we again skip spaces, and we have string nearby tickets /n, and after this we are interesting. So wait. If we try to read 1, 2, 3 as a list of ints, no parse, right? Because you need square brackets for this. Okay, so we cannot just reuse read precedent here. What we will use here is a sep by again. So we will have lift. Ticket will be here. Actually, it doesn't matter whether it lift. Let's keep lift here. Let's have ticket here as an F map. And let's have sep by 1. Wow, by at least 1 solve our problem that if we have empty list. So sep by 1, and we read read precedent for int, and we read character comma for delimiter, separator, and that's it. Yes, the only thing that we also need to read new lines, which also will be okay because we will use for reading tickets we will use sep by. Bam, ba bam. So 51. Sep by. Now I don't understand. This actual type read precedent. Yeah, I don't understand. It's the first argument of sep by, namely read precedent. Oh right, because it's read precedent. And we cannot use read precedent to construct read p. Alright. Do we have a read p in the read? Oh, read precedent. Okay, so what is read precedent? I haven't imported it. Read precedent is what we can do is read browse text parser combinators read precedent step. What are those functions? Reset step. So what we can do is read precedent to p, and that's what we probably want to do here. And everywhere where I use read precedent, but I only use it here, yeah, here as well. Can I use it somehow differently? I can lift the other function, but it doesn't make sense. Reset, step, what are all these functions? Package, parser, combinators. Parsec, yeah, this one. But what we are going to do is to say, do we have read precedent here? No. So then we need index. Wait. Contents maybe then. Yes, read precedent. So let's see index. Oh, not this index. Synopsis. Befell choice. +++ look get reset precedent. Okay, a minimal precedent. Wow, that's actually what I was looking for. Precedent, give you precedent and converts probably. What is step? Step. Increases the precedence context by 1. Reset the precedent context to 0. Okay. And we have converters. So what I will need to use probably are converters. I want to read precedent and convert read precedent. By the way, read precedent to p. Yeah, because I don't want precedence. I also can without use not lift but actually define read precedent, right? Because read precedent is just some it's data. Yeah, it's actually data. We can look for its source, but we can also use interpreter to see that read precedent. We cannot see read precedence. Okay. But here we using read precedence to P. Yes, that's correct. And using read precedent, and everywhere we're using read. Okay, let's just define the function readP. readP. Why is not it defined? I don't know. Oh, because to P now you need to give an precedence and will return. I see. So it's not that simple. But nevertheless, let's say the minimal P. Oh, soundtrack is ended. Let's just repeat it. readP is P readP. So yeah, it's taking read precedent. And it will return you readP. And it will equal read precedence to P. But also it will give minimal precedence. Parse error and 24. I don't. Right. Separate by. Actually, we cannot do this right because these are two arguments. We just can skip. Okay. Yeah, sure. We should have A and A. 51. Yeah, here we need to have now just readP. Read precedent. readP. Too much readP int with actual type read precedence A to readP A. 51. Alright, we don't need to be given read precedence because we already have read precedent. Yeah. No instance for read arising from use of read precedent. Yeah, so probably we have. Wait. In the 54. Yeah. Okay. You won't read? No shit. A would be read to the match string with input file in line 22. string with input. Right, because right now it's not finished. Nearby tickets, and now we have to have nearby tickets by sep by 1, and we read p for tickets, and we read new line, or rather skip spaces. Yes, we can do actually skip spaces. Just do we have, yeah, same here, skip spaces, and we are returning input file, fields, ticket, nearby tickets, type ticket with actual type a lot of tickets. What? Wait, read pair fields, that's fine, right? But then for some reason I try to read pair ticket. Nearby tickets. Right, because I have mistake in my type. There should be multiple tickets. Beautiful. So what we want to do here is read the read file head args, and we want actually file, and we want to have a read on the whole file, and then we want to print file. No social. Oh, right. So here it's EO input file to help the compiler. Now it's fine. Main example, ambiguous parse. That's interesting, but what's not interesting that I don't see error message, so I don't understand what's ambiguous about this. Okay, so we are reading sep by readpa, skip spaces. Wait, fields are separated by skip spaces. Alright, I see what's ambiguous. So when we say skip spaces, we don't actually know whether the new line is but. Well, so skip spaces, is it a bunch or is it many? I believe it's many. How would we debug this? Something like that. Oh, actually, new line. We don't need new line. Just let's use skip spaces to be consistent. Skip spaces. Boom, 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 boom. Yeah, I don't understand right now what's ambiguous. Yeah, and I shouldn't, because partial combinator should say me what's wrong. Okay, let's start with these fields. Let's comment all this stuff, and we will return input file fields, ticket, let's say ticket. What is default ticket? Well, what's ticket? Ticket is just list of number, right? So, and empty tickets. No parse. No parse. How so? So you say that sep by... Oh, right. Sep by 1. I forgot about this. Sep by 1. What's about now? No parse. But why? Wait, so if we try to read something like class 1, 3 or 2, 4 field, it's fine. What if we try to read /n? It's fine. What if we try to read sep by? Read what do we have? We have read p to s, cool. Sep by, we have read p for ticket, for field, and we separating by skip spaces. And we will pass class 1, 3 or 2, 4 /n, and then field 2, 4 or 1, 2. And we specify that we want to get field string. Yeah, we want to get string because read s has such type. Personal sep by 1. What's wrong with sep by 1? Don't understand. Why? Because yes. Oh, nice. Not really nice, but okay. Map m print reads. What are our options here? So first option is to read field with 1, 3, then try to skip. I see. So I need skip spaces 1, right? Skip spaces 1. There is no skip spaces 1. Interesting. So because I can just yeah, I see where ambiguity come into place. I guess we cannot use skip spaces because any skip spaces can be also omitted, and then the next field can be be parsing, which is not what we want. Yeah, so I guess yeah, we can only use p-char /n. I will want to have skip spaces 1, so it will know at least one space should be present. But we got what we got, and I don't see the value in having skip spaces here then. Nice. So we have field class, field row, field seat, and we have ticket. We have 4 nearby tickets. Yeah, that's exactly what I want. Okay, let's do actual task. So since we have input file fields ticket nearby tickets. Oh, right, if we add deconstruct, we don't need to specify what we are deconstructing. That's actually neat. Wanna become famous? By followers, primes and viewers. Can we ban this user? But I see it's automatically created. Added to block list. Okay. Oh, actually, does the restream shows you your stream? There is dashboard. Oh, streaming monitor. Okay. There are analytics, bitrate, FPS. So what we also can see is viewers. Maximum 1. We have channels here, followers, chat messages. Okay. Chat trends. Okay, I see. Okay. Okay. Input file. So now we need to process fields to get all possible intervals. Yeah, so what we'll have here is array of suitable numbers, or rather how do we call it? Valid numbers, right? We know invalid numbers. Import qualified data array as a. And what we can do is to have list array from 0 to 100. Of course, yeah, we can do one. So instead of putting here actual bounds, we will let's do minimum and maximum. Yeah, but minimum and maximum should be specified by the tickets, not by the fields. So we'll have minimum from all numbers in nearby tickets. Yes, sounds good. Concat nearby tickets. Only nearby tickets is a list of tickets. So what we need to do is to ticket numbers, nearby numbers. Let's see. Nearby numbers is concat. There is concat map, right? concat map. Yeah, cool. So we will have concat map to get the ticket. Okay, we don't have deconstructor, so what we'll need to do is to specify function which will deconstruct ticket num and will return num. Will this syntax work? So nearby numbers. So what we'll say, we will have nearby numbers, nums, let's say, numbers, nums, and maximum of nearby nums. Yes, sounds great. And print something, just because the last statement should be IO. No instant foldable T arising from use of maximum. Type T1 is ambiguous. What? Oh, I see. Yeah, that makes sense. What we need here is all the numbers by default are invalid. We can also do cycle, but I don't think that's... Wait, 18. So what's wrong with that? I don't see what's wrong. True. Parse error on input. Wait. If I say 1, 2, yeah. So if I say true, it won't work. Wow, interesting. Oh, okay, I see. So you need a space here. That's interesting. The type variable T1 is ambiguous. There are several potential instances. In the first argument... Oh, right, I see. Because minimum is defined on ORD. So it doesn't know which type we will be using. So what we can do here is array int to bool. Yes. Wait. Nearby nums. Should be... I don't understand. Understand. Minimum is unfoldable returns. So nearby nums. What is the type of nearby nums? Constructor tickets have one argument. Constructor ticket should have one argument but has been given more in the pattern ticket. Okay, I see what you probably want parentheses here. Am I right? Okay, let's say parentheses here. nearby nums can be function. Why? Ah, right, because you need to give actually nearby tickets to this one. Yeah. Okay, so can I skip this parenthesis? Probably not, because it will consider this to be 2 arguments, so you will need 1 argument here. Nearby nums, okay. So we'll have invalid numbers. So now we want to iterate through all intervals in the field and mark we want mark numbers as valid or possibly valid. So basically what we want is fold-L or fold-R, and we want here to insert key would be the number we're iterating with. So we will want to have insert value. Do we know what value? Yes, it would be true. Oh, actually we can just use set. Yeah. Why do you use array instead of set? Is there a reason to? Just because we can. Also set doesn't grow dynamically. Yeah, I don't think array is a good structure here. Set will be better. So list array, what we say is set. Actually don't need to have set, or rather we will have set empty, and we will set, or rather we need valid numbers. Okay. Fold L, so then we will have insert, like, right? We'll have insert. So set insert, right? Yeah, sure. Fold L, set insert, the value is coming in, so we actually want folder, just not to flip arguments. And the left one will be, so the element will be the number. Oh, I see. So the thing is, our left is not a number because we are iterating through intervals. But we can say it's a number. So our element will be a number, and our initial value will be valid numbers, and our list will be. So what we'll do here is fields, field. We will say intervals. Map intervals, so we'll get all intervals, but for each interval we will say range. Okay, so what we can do is to import actually array data array or data x. Yeah, data x. Nice. And we have in ix index we have range, and that's exactly what we need here. So import data ix range. So we have intervals, and for let's say concat and then map. Yeah, so we will concat it nevertheless, and we will have range for each of the intervals. Yeah, and finally here we will have a set of valid numbers, right? So we don't really need here valid numbers, we just use empty. Yes. So now the real fun begin. What we'll have for each ticket, we will check their numbers. And what do we need? Scanning error rate. Okay, so we'll just need to sum all numbers. So how to do this is just concat. We are taking nearby tickets. Oh, nearby nums. We already have nearby nums. We don't need concat. We can just determine whether we can filter by them being valid numbers. As so, if the valid numbers they don't pass, so what we say is not valid number. Oh no, there is no S, there is S member and not M member, right? Not member. So yeah, not member here. And set should be S, so we will use not member as such. Filter and sum and print. Couldn't match int with list of int expected type. What? Alright, so we say range, but we need concaten again, right? Yeah, we want to concat again, so we can use actually concat map, and also here we can use concat map, right? Cool. $71, yeah, 71 is a correct answer. Let's do it with our actual task. Let's copy the task first. Okay, your ticket. I copied it twice. Okay, so I want to insert. ticket. Wait, I have two lines with your ticket, and I want only one. Why do I have two? I don't understand. But let's try again. Don't understand. 270, that's proper. Asking. Okay. Yeah, cool. Day 15, section 16 start. So, and now that you identified which tickets contain invalid values, discard those tickets entirely. Use the remaining valid tickets to determine which field is which. Using the valid ranges for each field, determine what order the fields appear on the tickets. Wow, that's interesting. The order is consistent with all tickets. If seat is the third field, it is the third field on every ticket, including your ticket. For example, suppose you have the following notes. Based on the nearby tickets, in the above example, the first position must be row, the second position must be class, and the third position must be C. You conclude that in your ticket class, once you work out which field is which, look for the 6 fields on your ticket that start with the word departure. Interesting. What do you get if you multiply those 6 values together? Interesting. So let's use example as the second one. Example 2. Wait. Also, let's rename example to example 1. Alright, right. Great. Okay, how should we determine? Do we have intersections? Yes, we have. Right. So we need somehow to get a... Okay, so I think we will need to calculate. Okay, so first we can totally easy to calculate what positions of the field aren't fit for what field. So we can get for each position what are the options of our fields. how then to decide? I don't know. It would be ambiguous. So yeah, by calculating all possible. Okay, so we can say if we are given an ambiguous. If we are given an ambiguous input, then we can conclude that if we found valid combination, oh no, it won't be ambiguous. So what could happen is that some position is valid for 2 tickets, but other position is valid only for 1 ticket. Can we get also the? Can we get a loop here? So we say the first position is for 1 and second field. The second position is for second and third, and the third position for the first and 3. So that would be ambiguous. So we can assume that this never happens. So let's assume that. So we must check each position for what tickets will satisfy, what fields will satisfy this first position. Let's just print so we can see. So valid numbers. What we'll need here is valid tickets. So right now we have nearby nums, which now we don't really want to have. Valid numbers is something we want to have. Valid tickets is nearby tickets, and we filter them by. So I guess having a constructor named constructor is not that bad. Ticket. You just have like nums, and that's all. So you don't need to use. Yes, there's this weird function. So what you say here is nums. So for this ticket, nums, all of them should be valid. They are valid if they are member of valid numbers. Yeah, sounds great. Yeah. Valid tickets. What else can we do? Okay, valid tickets. So for each position we should have a list of fields that satisfy. So I guess maybe we should have a map which maps the specific number to the list of tickets, list of fields it can be part of. So instead of using set, here we'll have map strict as m, and our constructing will be not just inserting, but much more complex. We will use alter, and we will say if nothing, then we'll just use so it's folder, so the new value on the right, accumulator on the left, no, accumulator on the right. So we have function with map on the right, we don't need to have map, but what we need to have is number. What we are iterating through is fields. Oh right, I use concat map, that won't work here, and concat map intervals fields. Yeah, so concat map intervals here won't work. What will work is just map for intervals. Concat map range, yes, but we need to put it inside, because for each field we have interval and concat map range, and for each range we can say wait, we need to use fold R, we can just use from list, right? Why haven't I used from list? So from list is not working here. Set, it would work perfectly. Map, it won't work because we need to add more elements. So elements are added through all fields, right? Yes. So fold R should be on the top for sure. But we should have an indication which field the number is coming from. So when we map fields, we actually need to concat map. Yes, we still need concat map fields, but here we'll have concat map intervals. We will get intervals. For each of them we have range, map range, and we say concat map. That's perfect. What we'll need also to do here is say zip field number or zip field name. So let's say our fields from now on they have index, and they actually do have it. So when we say fields, what we actually mean here is zip 00 fields, because we want to have index. And here what we actually mean is not concat map like this, or yes it is, but we mean fmap. So we want this function to work only on the second, which is the field itself. But we don't want this map modify the index itself. So when we say like this, we will have pairs of index, and second element is the list of possible numbers. So what we want to do now is to expand. We want to have, no, we don't actually want. That's completely fine. Here an element would be not a number. Here an element would be an index and the list of numbers. So what we'll say here is index field index. Second argument is actual map. Yeah, we will have here empty. So what we want to do here is alter, and we want, if there is nothing, we want just to have field ix. Wait, alter maybe just field ix. Yes, that's right. But in case something is there, we also want to have just. So just and maybe something. So just maybe field ix, and here we want to process. It should be field ix. Okay, sounds good. What do you say? I say that we don't use num in any way, because here we have not only field index, we also have numbers, right? So what we want to do here is not just alter, because alter will add sure field, but the key is nums. Yeah, so what should we do is hold R again. Yeah, okay, that seems too stupid. So we will say field x and num, and field x something we are going to add, but also malter import data map alter. After the function we will have key and key, wait, folder function. There is folder function, there is alter function here. So after this function we will just pass the key, and key is the number. So here what we need to do is to expand. We have a pairs where the first element is index and the second element is a list. What we want to create is a list of pairs. I guess the best way to do it is a list comprehension. Or another concat map, which will have x nums and will output map ix on nums. Okay, maybe list comprehension is better here, because we also have zip and fmap. Actually, fmap will be better this way, because not really, if we have concat, why not? Yeah, I think actually, yeah, let's try to do this with list comprehension, which will be x and number, right? And we are starting to iterate with index. We will have index, but what we'll have instead is nums. Zip 0 fields. Okay, so what we actually have is field here, and what we'll have next is intervals field, but concat map range. Concat map range. Fmap is not needed anymore, but this would be a number now. That's all? Interesting. So this one is not happening? Yeah, that's actually all, because we use do notation. Also we can use this way. But the previous was better. Okay. Okay. Seems really good. So what it will give us? Valid numbers, which is being used. So what else we can do? So since we have valid numbers, we have valid tickets. Sure. So for valid tickets we need I guess for every position we'll need to okay, so let's say positions. So positions will be so we have valid tickets, and we for each of them we say please nums, but also we say please take something. Okay, so we said please take something. Let's do list comprehension again. So much fun, right? Actually, it doesn't make sense here. So for valid tickets or it does, I don't remember. Does it make sense or it doesn't? I don't know. Let's try this out. Valid tickets will get numbers and we need position here, right? So question, how do we get this position, is through iterating. So yeah, I think it list comprehension does make sense here. So what we'll have, we can just put it here. And what doesn't make sense is to say nums and we give position. Okay, so we need actual nums, or should we have a ticket? So what we'll have here is one element, right? This one element will be a list which is pair. So positions here is from 0 to length -1, length of something -1. What is something here? That's head valid tickets. Head valid tickets. But it's not just head, it's also nums. And -1, yes. That makes sense to me. Should we iterate through tickets? I don't think we actually can. Yeah, so we will not have map. No, we need map because we want to return the list of lists. So it will be map using the position. We also can use 1, but index here is using 0, so doesn't matter much. Yeah, I think we got positions. So what is positions right now? Positions are the number in this position. So what we need to do right now is to check. Okay. So okay, we actually can do. We can use here additional iterations through. We say number. But we know, yeah, we must know. So yeah, we must know which position it is, so we cannot, or which ticket it is. Do we should we? No, we don't care what ticket it is. So what we can do is just to iterate through numbers. Iterate through tickets, right? So we'll have for each ticket, and what we'll get is a number. But we have only one number. For each ticket we'll have only one number. Yes, and this number we will convert. Yeah, but we need still group them by the position, and that's critical, so we cannot use a second iteration here. We need a separate iteration for this. And for each of the positions we can say possible fields, or rather just fields. And for each of the position we'll say that we have list of numbers. So what we need to do is for every number in one position we can do, let's use let, and we can just wide let also. I don't know how the indentation here works. So for each position we are saying map each number, and we want to get m in valid numbers. For this number we want to get a list of possible fields. So now we have possible fields, and what we want to have is a not union, but in each list for each ticket, because in the positions we by ticket. We want to have find tickets that exist for a field which will be suitable for every ticket at this position. So we need some functions that will intersect exactly. So we have a list. Can we have a function intersect? I believe it's in data list. Intersect. Yes, perfect. So we can use fold L1 to intersect. We have fold N1. Nice. Yes. So since we have a list, so what list of valid numbers, here we use for del1, and we use function intersect, and the accumulator will be the first element, and the elements are our possible fields. Okay. We cannot use fields twice, but what we can use is intersect. We can change the variable name to sound like it's not fields, right? Position fields. So at this position, what fields can we have? And let's for now just print position fields, just to see what we'll get. Valid tickets. Where do I use valid tickets? As member. Yeah, we need to have M member, right? We have M member. Doesn't matter if it compiles. Yes, of course it is. So let's say example. Sure, example 1. So so for example 1 we have 3 positions. Wait, we are trying on example 2, right? Yeah, here we have example 2. It seems like task can be a bit trickier, but let's see. Okay, so for first position we say that only first ticket can be used. That's correct. Because for zeros ticket cannot be used because 3 bigger than 1, and wait, zeros can also be used. Zeros field class. No, class cannot be used because 3 bigger than 1. Then we say that 5. Okay, the row can be used. The seat. We say that 15 is not. So okay, so what we have here is that it's not ambiguous, but when you found the position that can correspond only to 1 ticket, you need to remove this ticket from every position, and it will be ambiguous if at some step we will have no positions that have only 1 ticket. Yeah, if it either will be the last step when we don't have any tickets assigned to any positions, or it should be. Otherwise it's ambiguous, so we probably won't solve it. So what we are gonna to do here is So yeah, now we should repeat the process of finding correct position. And to find correct position, so technically the graph should be drawn here. Not really. Not really. Yeah, so position fields, right? So we need to now iterate through position fields until we get all tickets assigned to positions. And we need to repeat this process. We need to repeat this process until we will have some different map, the assignment map full, let's say like that. So let's position field would be our map, doesn't matter. So we iterate and there is some function and we use position fields as our accumulator, but what else we need to use is a map assignment. This would be our final result. So here we have a function that will take position fields and as map, and what it will do, let's say we have a different function. Find the ambiguous non-ambiguous field position, let's say position or position, yeah. It will take position fields. So position fields is a list pos field. So for each position we will have a list of fields that will satisfy. And assignment map is a map where we say int yeah, let's have some synonyms here. Type position int and type field index. So here, since we for each position we have field index, and here we have for each position a field index. Non-ambiguous position. And so yeah, it will take the list and it will return the mapping. Positions. So what it will do, it's a first a zip to determine position. Yes. With positions. And here we will have filter on second, because if it's singleton, so singleton is length equal to 1. So for and basically that's it. Let's say it will be pairs actually, just for simplicity. We always can convert to map if we need. And that's it. But it should not be only. We can use cat made this. So yeah, we can use filter, but we also can use second. Yeah, I don't think let's use list comprehension. Which is index position. And we want to return index and indeed position actually. Position and field index. Position contain field index inside. I see. So what we want to return is positions. Yeah, so basically fields, and this is position, so we will return position. We return one field, so filter in this case will be that length of fields is equal 1, and here field will be just head fields. Cool. Non-ambiguous position. So what iteration will be giving us here is we will have non-ambiguous positions, and we will need to first to remove these non-ambiguous positions. From pose fields. So what we will need to do here is remove them from pose fields, but also add them to assignment map. So how we remove elements because we have this function, right, in data list, or this function. Yeah, it's ridiculous. So one type has it just slashes, and this type has its backslashes, right? So backslash data list backslash is 24. Yes, ridiculous. Post fields. Without non-ambiguous poses, but also assignment map. Do we have insert many? I believe we don't for map. Data map strict. Sort of like this. Yeah, I see why it's backslashes. It's a bit different. No, I don't understand why it's backslashes. Yeah, we can do union. Wait, we don't know union, we need actually without. So yeah, let's do without. No, we need to add, so it's actually union. M union and node amp poses. Wait, so node amp poses is actually a list, right? So list is something we need, but here we need only fields, position fields, right? So we need to remove only fields, so it would be map second and number of poses, and so the second element here be using assign map and of m from list non-amp poses. Seems good to me. Now we only need to, yes, wow, that's a function. Probably deserves a name, but I don't care right now. Parser, okay. Wait. So we cannot actually do this. So let's call it step. I have everything. What this is functions have. Yeah, and here we can have where, and here we can have step. What do you think? Will it compile? Not the scope, yeah, because this operator should be included here, but also not member, not in scope. 37, not member. I don't know why they use. Let's use M, not member. Nearby nums. Ah, right. This is previous. Something is wrong. expected type is list on field X, actual type integer. In the expression pos fields, I don't know, I couldn't care less. Step. So position of fields should be a list of... Oh right, so we need... Oh, that's right, so it's not... We need remove for each of the positions. So what actually will be here is a map of this function. Map, that's so amazing. Beautiful code. Uh, 36. Iterate. So yeah, IO. That's quite good actually. So what we need to have here is drop while. Drop while second, which is a map. Has length, m length. Size. So when while size less than the amount of fields, so length of fields, technically we have here a map of positions to fields, so should be length of positions, but I couldn't care less. Oh wait, actually if I couldn't care less, why do you... I'm getting here number of positions in the ticket. I can just say length of valid tickets, no, length of fields. Yeah, nice. Okay, so second drop while, yeah, also head, but also second, right? Second is a map, which is totally fine. Let's print a map. Wow, we even compile. So we say that for first position should be field 1, for field 1 which is a row, for second position is zeros field, which is class, and for third position is seed, which is perfect. So what would be result is once we need field by the names on your ticket that starts with the word departure. What do you get if you multiply 6 values together? So the hardest part here is to determine whether some string has prefix, because it's not hard actually. Yeah, it's super easy. We can just let's Google for this sort of like prefix. Text pattern doesn't seem... Prelude doesn't seem to have such function, but we can write it. So here we have mapping from position to field. Pos field, right? Pos field. So post field, and we need to filter. We actually need the opposite, right? We need field pause, but it's easy to convert. Now we just map through my ticket, get the field and check whether, so yeah, sounds pretty awesome. So we can actually print result. We will have prod or product, yeah, product, probably product of. We are mapping through ticket, nums of the ticket, and for each num we will have post field, right? So we are zipping with zip this, or how do we? We'll have a number, but we need to filter. So what we are going to modify is second one. So I will prefer it to be here, post field, and because we can do here fmap. So what we can do is post field to modify. Do we actually need ticket? We don't need this. So what we can do is to say post field map. We know the number of the field, index of the field. So what we will do is in fields we will get this field, zip nums ticket. Yeah, we want to go to zip this ticket, and then we want to filter only those which will have so let's create a function has prefix, and we'll have prefix, the string itself, and bool, and has prefix. We'll take str prefix and we'll zip them, but it will zip them with zip with equality. So results should have all of them should be equal, specifically zipped. So technically, if the first string will be the prefix of the second, it will work as well, which doesn't work for us. Okay, so what we'll do is we'll have condition, very simple condition. If length str lowers the length of the prefix, then return false. Otherwise, do actual work. So now what we can do, since we zipped, we want to filter, and we want for second. Yeah, because what I see what we also want to do here. It's not also map field. We want also to have here the name of this field. So since we have the name, now we can use a second, and we can say has prefix, and wait, prefix should be the first. I don't know why I haven't put prefix the first. I don't know. I really don't know. Prefix is departure. Departure. So if second has prefix departure, just a map first, actually, as well, and just simply give a product. What do you say? I say, oh yes, string. No. Couldn't much expected with actual bool. Possible call ZipWis is applied to many arguments, but ZipWis should be applied to many arguments. ZipWis. What? I don't understand yet. What's the line? 45. Yes. So what's wrong with this? Couldn't match tag with actual type bool. ZipWis is applied to too many arguments. In the second argument of namely ZipWis, third prefix. In the expression all, I don't understand. I really don't. Prefix and string, and you give string and prefix. Let's give just all. What's all mean? All is function. Okay. Can we just concat it then? No, we don't want to concat. We want actually what's different? Concat M, right? Or something like that. Fold M. Monoid. What does monoid do? M concat. Okay. M concat. Okay. M. Why do we want mconcat? Because mconcat will return false if anything is false. Am I right? Concat true or false true. No instance for monoid bool. Wow. Okay, so mconcat is not an option here, but we have n, right? Such simple answer. So we have n. So yeah, we'll use and here. Cool. 39. So here we say couldn't much expect the type is map. The second argument of map, namely post field. So post field is a map actually. Right. Post field is a map. So we want not to use fields. So for specific position we have specific field. So what we want to have is to iterate through positions. Yeah, what we want to have is iterate through positions. Oh, we can use, no, we cannot use. So post field is a map. So we cannot use the idea that it's sorted. No. So post field. What we are saying here is we want elements. We want from some positions to want also to sort, but that's too much. Let's say LMs assocs, assocs, and for each of them we want we know the number of the field. Do we care about the position? Oh, so what we are doing here is like zipping these positions, but instead we don't need because we know the position. So it's not fields. First of all, that's association. So what we need is fmap here. For each of them we are working only with the second, which is a field. And for it we will choose field and name. So now for the second we have has prefix departure, and we will choose only positions, and we will learn products. Wait, so we don't know. Wait, we are not saying position here. Yeah, so what we want to say here is map first. That's totally fine, but what we also need is to map ticket, because we are giving position index and not the actual value in the ticket. Couldn't match integer with the actual ticket. In the first argument of namely ticket. So we have ticket. Alright, so we need ticket. In ticket has nums. So what we'll have here is nums ticket. Nice. Main example 2. 1, 1, 1. That's not correct. Wait, that's correct. Class row and seed doesn't have them. Why 1 then? Because product of... yeah, they don't expect us to handle 0 tasking. Let's see. Nice. Okay. So what's interesting about this task? This would be the last task we've done today, but what's interesting about this task? First of all, parser combinators are amazing. Second of all, second of all, so code is messy here. Oh, wow. Let's say git add 16, git commit, delete comments, git push. So first of all has prefix. Yeah, first parser combinators were really handy. Otherwise, I don't know what to say about this. I used a lot of comprehensive, but not enough to make something of it.